All right, so remember we were talking about quotas and weighted voting and all that kind of stuff? We were doing the examples. I gave you a couple of examples, right? One more time, just really quick. I gave you the example of what if you and some friends set up a system like this. This is the quota. Remember, the first number is the quota. That's how many you need to pass something. Say you and some friends decided you were going to do a investment company, right? And this is you here. You have 9 votes because you only contributed $9,000, and they all pitched in $10,000. You guys are going to take your, whatever it is, $39,000 and invest in different things. And you decided it takes 30 votes to make any decision. That's what the quota is. How many votes it takes to make any decision. And that would be a bad system for you, right? Because you'd have absolutely no power, actually, right? We talked about that, how there would never be a situation in which your vote makes a difference. If 2 people wanted to invest in Apple stock or whatever, and then you said, I'll join you. Well, that still doesn't make it a go, huh? That's only 29. If the other 3 friends wanted to do it, but you said no, well, it's still going to go because they have 30 votes. See how there's never a situation in which your vote matters at all? Literally, you might as well not show up at the meetings. Your vote does nothing. You being in never makes it go. You being out never makes it fail. You do nothing. You would be, what's the technical word? Yeah, dummy. Yeah, that's really the official word. You're called a dummy in that system. You're not alive in that system. You're just filling space. You have no real power. And then I talked about the red party, green party thing, and I said, what if there was 99 votes for the red party and 98 votes for the blue party, and then 3 for the green party, right? Did like a political thing. Say there was 3 parties in some political system, red, blue, green, and there's 101. Again, that first number with the colon, that's the quota. So if there's 101 votes to get anything passed, when you first look at it, so then the trick, what we're trying to do here, because there are real life things, you know, we're like stockholders, and the electoral college, how we vote president, is actually a weighted voting system, right? Every state has a weight. California has a number of votes, and right, 54, whatever it is. Anyway, so there are weighted voting systems in the real world. So what we want to do is use math to come in and help society think about where the power really lies in a weighted voting system. That makes sense? So what we're doing here in Chapter 1 is how can math help us in society? Chapter 1 was all about really, producing the fairest way to vote where everybody just has one vote. Chapter 2, it's looking at weighted voting, where different people have different amounts of weight on their vote. Where's the power, really? That's our objective in this chapter. So, you tell me, what did we learn about the power in this situation? You remember? We did it real quick right at the end.
You said they're about equal?
Yeah, good job, good memory. Yeah, it turns out they're all equal. Even though green's so stinking low, you're thinking, no way. They've only got 3 votes. You tell me they're equal power? But if you think about it, they really are. Because suppose if the quota is 101, now if we change the quota, of course that changes everything. But if the quota is 101, if it takes 100, if they're doing some political thing and it takes 101 votes to elect the president or to whatever, then if the red party and the green are both for it, like if red and green, that's 102 votes, then they get to pick the president. Or if the blue and the green like somebody, that picks the president. Or of course the red and the blue, no question there. If those 2 like a candidate, they get elected as president. But green has just as much power as anybody else. Basically, if any 2 of the 3 parties come together to support a candidate, they're going to be elected president, aren't they? So green has complete equal power with red and blue, which seems totally unfair and wouldn't seem that way at first until we gave it a little more thought, huh? And that's what the math is supposed to do. The math is supposed to come in and look at the numbers, and although at first, if you probably just grab somebody off the street and say, political party, 101 votes to pass anything, 99 for red, 98 for blue, 3 for green, who's got the most power? Well, they would go, well, red, for sure. And who's got the least power? Well, green. You say, yeah, does green have a lot less power? They'd go, yeah. But really, it's not true, huh? When you give it a little more thought, it's not true at all. Green has complete equal power in that situation, right? It just needs green and one other group, right? No group can go do it alone. What if red alone likes some candidate, but the other 2 groups don't like him? Can red elect that candidate all by him, that party all by itself? No, it's not enough. You need 101 votes, you've only got 99. If blue alone likes somebody, they can't do it. If green alone likes somebody, nobody alone, no party alone can elect a candidate. It takes two parties to get together to agree to have enough votes to support a candidate, right? And it can be any two. It can be red with green or blue with green. Blue and green is 101. It's enough. Or, of course, red and blue, no question. So that's equal power. In the end, that's equal power, isn't it? Green can get things done with just as much efficiency and power as red or blue. And that doesn't seem right, does it? That doesn't seem like it should be that way. So in reality, what the math will do in these kind of situations, and has helped over time, is math will come into these kind of situations and go, okay, if you guys want it this way, fine, but do you realize when you set it up this way, you've given green equal power? Of course, green would be thrilled, but red and blue would go, what? That's not fair. We need to restructure the system. So that's what we're looking at. One of the places where this is used is the United Nations. I don't know if you know how the UN works. I don't exactly remember either. There's something like 5 big powers: the United States, Russia, China, England, France. I can't remember. Something like that. There's like 5 big powers that are always, they're called, I don't remember what they're called. They're always on the United Nations. They always cast a vote. Like whenever the United Nations is deciding what to do about police action in this area or to stop somebody from doing something bad in this area or not, right? 5 major countries always vote. And then did you know there's like 10 smaller countries that get like turns voting? Like for a few years, they each get one vote, then they rotate off. You can read about it on Google or whatever. But that's one situation where you wonder, so how much power does China really have or the United States really have? And how much power do these smaller countries, like Brazil, when they only get on once every 3 years or whatever, so how much power does that really give them? That's the kind of thing, if you were Brazil, you'd want to know, and if you're America, you want to know. How much real power do we have in this situation, given the setup? That's what that's what this chapter is all about, is learning to figure out where the real power lies. People want to know that in society. So, here we go. Here's our first one. Let's just get used to the terminology. Is that too small? Can you read that? Let me make it a little bigger here. So it's 68 colon, so that's the quota, right? That first number. And then 29, 25, 17, 12, 6, and 5. These guys here are all called the players. I don't know why we call it that way. Find the total number of players. This is the first player, second player, third, fourth, the different people in the in the power setup. So there's, looks like 6 players in the game is the answer to question A. This is the homework right here. So 6 players in the game. Find the total number of votes. Now to find the total number of votes, we just add up all the players. So we're just going to add all these up. Total number of votes, whatever that adds up to be. 29, 20, it's a 5 there.
94.
Is that what it is? You're quick with that calculator. 17, 12, 6, 5, 94. So 94 total votes. That's the part B. And find the weight of P2. Do you know what they mean there? Player 2, yeah. They just mean the 25. The weight, the number of, they call that their weight, the number of votes that player 2 has in this system, 25 votes. That's part C. And now part D, find the minimum percentage of the votes needed to pass a motion. Round to the next whole percent. Okay, so what are they talking about? Well, how much does it take to pass something in this particular system?
68.
Take 68. That's the quota, huh? The quota is how many it takes to pass something. So the quota, that's how many number to pass, equals 68. Now they didn't ask number, they asked percentage. So whenever they say, like if I said, hey, I think 30% of this class is going to get an A. So whenever you do percentage, what does that mean? That means the part over the whole, doesn't it? Might mean like 6 people out of 30 or something, right? Does that make sense? It's always the part over the whole. So whenever they ask you in any of these kind of questions, a percentage, any of these chapters, a percentage question, you should always think, oh, they want me to give the part over the whole. So we're saying, what's the number to pass? 68 is the part you need to pass out of the whole number of votes. What's the whole number of votes? That's the 94. Yeah, exactly. Does that make sense how we're coming up with that? So it's 68 to pass something. What percentage is that? Well, it's the part over the whole, 68 over 94. You guys have a calculator? Is that like 70% or something like that? 0.68, 69, 70, 71, something like that. Point 72? Can you, can you give me one more number? 723? Okay. That's the decimal. How do we change 0.723 to a percentage? Two places, right? That's why that symbol has two zeros in it. I don't know if you ever thought about that. That's why it moves two places. So 72.3%. And they said round. Now, careful. They're being a little tricky here. They're saying rounded to the next. Look at that word, next. So I'm actually going to round that up. So in other words, the final answer they want is 73%. Even though it rounds closer to 72, they want me to go up because what that means is if it takes 72.3%, then 72% isn't enough to pass anything. It really takes 73% to pass something. That's why they're doing that. Is that good?
How'd you find the weight of P?
The what's that?
The weight of P?
Oh yeah, it's just right here. It's just the same. So this is the quote is the first one, and then it's just the second one over, the player 2. Player 2's weight, just the number there for player 2. Good. Other questions on that one?
Wait, can you hold on. I'm confused. So the red part is for A and B, and then the black part is.
Oh, the red. So
Did you
question
just
A.
solve all of it? Is my question.
Yeah, I just finished it all.
Okay.
So question A, find total number of players. 6. I just counted them. 6 players, and B is total votes. Add them up. Weight of player 2 is 25 right here. And then minimum percentage is that 68 over 94. Good on that? Any other questions? All right, it'll be on YouTube also, you know. Okay, so number 2. In the following weighted voting system, determine which players, if any, are dictators, have veto power, are dummies. So they're going to give me the 25, 15, 10, 7, and 2. Okay, so this is player 1, player 2, player 3, and player 4, and this, of course, is the quota. Okay, so I've answered the questions there for you, but let's see how I got those answers. So the first question is, determine which players, if any, are dictators. Now, we all know what a dictator is, right? A dictator is one who has absolute total control in the situation, right? Absolute and total control. So, okay, so a dictator decides what's happening. So, how do you know if somebody has well, if it takes 25 votes to pass something, that's what quota is, right? The number of votes to pass anything. If it takes 25 votes in this system to pass anything, what number, wouldn't we have to have one of these guys having 25 or more? To be a dictator. That's exactly it, right? So like if this guy, right, if this first player was 25, then he would be a dictator because that means he could pass anything he wanted all by himself. That's what a dictator does, right? Anything they want all by themselves. Okay. So we don't have any dictators here, do we? So that's why I said there's no dictators. There's nobody that's 25. So let me just write that. Dictator must have weight equal to the quota. Right? They got to have as much weight as the quota so they can get something passed all by themselves. So there's no dictators in this setup. Let's go to question 2. Which players have veto power? Who has veto power? Now, you know what that means, right? Like the president can veto anything he wants, and that means like if the Congress passes a bill or whatever and comes to the president's desk, he can say no to it, and then it's a no. Now, he can't pass anything he wants, but he can block anything he wants. And then they could override with 2/3, but anyway, we're not getting into all that. We're just saying, what does veto power mean? It simply means you can say no. It's different than dictator, though, because a dictator can not only say no, he can say yes. He can do whatever he wants. at any time he wants, right? So the dictator, yeah, let me be clear on that. Dictator can say yes or no to anything he wants. Whereas a veto power means you can say no to anything. Well, that's not putting it very clear. How about I say it better than that? How about I say can block anything? That's really what it is. You can block anything you don't want passed. I'll put in parentheses. You cannot pass anything. You can't make any motion pass, but you can block anything. Whereas the dictators, let me get rid of the yes/no thing. That wasn't very well said. The dictator can pass or block anything. Right? So a dictator can pass or block anything. And veto power can block anything, but they can't pass anything. So, let's take a look. How do you know then if a player, let's go up here and say, how do we know then if these players have veto power or not? Well, you just give it a try. So you just go out up here, let's take a look. Let's come on up and ask the question. If this, here's our setup right here. If player one says no, let's just suppose, so let's test if it's player one. Kind of bring it over here, I guess. So if player one says no, but all the other players, player two, player three, player four, if they all say yes, is player one able to block it?
Yeah.
So let's see. Cross off player one, right? Suppose he says no. He says, I'm not contributing my 15 votes. Right? His weight, his contribution is 15 votes. If player one says, I'm not contributing my 15 votes, but all the other players say we like the whatever it is they're voting on. 10, 7, and 2. What does that add up to be? Right? 7 and 2 is 9, and 10, 19. So those three, without player one, would only have 19 votes. Is that enough to get something passed? What does it take in this system anyway? 25. So they need player one to also throw in his 15 votes, and then they'd have plenty. But if player one says, no, I don't like that thing, then it's blocked, isn't it? They can't do it without him. Do you see how he has veto power? There's going to be, player two is also going to have veto power. We'll see in a second. But so far so good. You see player one does have veto power, meaning if he wants to block something, he can block it. Now he can't pass anything he wants. See the difference? He's not a dictator. He can't say, oh, I really want to invest all of our money in erasers, and everybody goes, that's crazy. Well, then he can't get it done. He's only got 15 votes. He can't himself, all by himself, pass anything he wants. But if all of his friends want to do Apple stock and he says no, it's not going to happen. He can veto anything he doesn't like, but he can't pass anything he wants. He's not a dictator, but he does have veto power. How about player two? Let's go to player two now and see. So same thing, you just cross him out and you just ask, does everybody else without him have enough? So what would the other ones have? If it was player one, if this one, and this one, what would they have?
24.
Is that what it is, 24? So 15 plus 7 plus 2, yeah, 24. 24, oh, not quite, huh? Almost. They need 25 to pass anything. They can't quite get it done without player two. So player two also has veto power. Does that make sense? If player two doesn't like the Apple stock or whatever, then the other three people do. Too bad. So all player two has to say is no to anything, and it doesn't get done. He has veto power. So player one and player two have veto power. Let's keep going. What about player three? So if player three says no, I don't like Apple stock, and the other three want to do it, so that'd be what, 15, 10, and 2? Is that 27? Can the other three get it done even though player three doesn't like it? Yeah, they can get it done. So player three cannot block things himself. He does not have veto power. You with me? If player 3 says no, but the other 3 still like the apple stock or whatever, then they're going to still go ahead without him. It's going to get done. So player 3 does not have veto power, just because he doesn't like it. Now, some other people join him. He could, if a couple of them get together, yeah, then they can block things. But veto power means you alone can make something blocked, and player 3 alone can't block things. We good? So then the only ones that have veto power then are player 1 and player 2. That's why I chose that option. I didn't even check 4, but there's no way player 4 could have veto power because he's got less power than player 3. Makes sense? If player 3 if a 7 doesn't have veto power, then no way a 2 can. Don't even need to check. Good? So just player 1 and player 2 have veto power. Is that making sense? So we have dictator, veto power, and now number 3, dummies. And you know what dummies is? It means no power at all. Is anybody there a dummy in this situation? Now it's harder to figure out than you might think. You can tell I'm answering the question. It's actually player 3 and player 4 are both dummies in this situation. Now they don't look like dummies. I mean, 7 votes? That's a dummy? Yeah, you're thinking well. Exactly right. You see, the 15 and the 10, they can get it done without player 3 or player 4. Does that make sense? Let me put it even more clear. There's never a situation in which player 3 or player 4 will make a difference. Let me try to draw that for you down here a little more clearly. So try to think about it for a minute. So let's try to make a situation up where they really make a difference. So what if we say, okay, it's 25 votes to pass anything, right? Let me put these back the way they were, 7 and 2. So it's 25 votes to pass anything. What if player 1 with 15 votes likes apple stock or whatever, and player 2 with 10 votes likes apple stock? That's 25 votes. They're going to do apple stock. What if player 3 says, oh, I like it too? Well, great. We don't really need you, though. We've already got it done. Player 3 goes, oh, I changed my mind. I don't like apple stock now. Okay, we're still going to do it. Right? You see how player 3 is a dummy in that situation? Now, let me be a little more careful. You're only a dummy if there's never a situation in which you make a difference. So yeah, he doesn't make a difference in that particular situation. If 15 and 10 like something, whether he's in or out makes no difference. But are there maybe other situations where he would? And it turns out there's not. I mean, you just can't come up with any situation where he makes a difference. But maybe it'd be helpful if I said, when would the 10 make a difference? Is the 10 not a dummy? Yeah, the 10 is not a dummy. He makes a difference sometimes. When? Well, what if the 15, player 1, liked apple stock or whatever, and the other 2 guys said no, and 10 was making up his mind. The 10 was like, I don't know if I should do apple stock or not apple stock. The player 1 wants to do it. These guys don't. They've made up their minds. If player 2 says, yeah, I'm in, then that's 25 votes. It's going to go. They're going to do the apple stock. If player 2 says, nope, I'm out, then they're not going to do apple stock because they don't have enough votes. See how he really makes a difference in that situation? There is a situation where the 10, player 2, makes a difference. So he's not a dummy. That's what it means to not be a dummy, where there's a situation in which your vote would actually matter. It would actually change the outcome. If there's never a situation where your vote changes the outcome, you're a dummy, really, effectively. And so that's what we're saying about the 7 and the 2. There's never a time where it would be below 25 and the 7 would bring it above 25. Does that make sense? That's where it goes from failing to passing. When it's below 25 and then makes it hit 25 or more. Right? You can never add up the numbers and have them below 25. And then the 7 makes the difference. You can take this is below 25 right here, this 15. But yeah, the 7 adding to that only makes it 22. That doesn't make the difference. You might think, yeah, but if the 10's on there, well, yeah, but then the 7's still not needed. The 10 would be enough without the 7. So, you guys getting the idea? So the 7 never makes a difference, and if the 7's a dummy, for sure the 2's a dummy, because he's even less powerful. So 7 and 2 are dummies. Now, it's not always this way. There's all kinds of scenarios. It's not always the bottom 2 are dummies, and all kinds of different things can happen. You just kind of have to reason it out. Now, notice I didn't really give you Yeah, I didn't really give you an easy, I wrote out the rule for dictator, and I wrote out the rule for veto power. But beyond that, it's kind of touchy-feely, isn't it? I mean, if there was a step 1, step 2, step 3, I'd give it to you. But there really isn't a step 1, step 2, step 3. You just kind of get in there and ask yourself, do they ever make a difference? I don't know how, I think just seeing more and more of them will make more sense for you. So it's like, all right, let's do it. We'll do number 3, then we'll do number 4. So number 3 here, we have a weighted voting system. Let me put it in there. Q for quota, we're not sure what the quota is. 12, 8, and 1. Okay. Okay. Now it's asking us some pretty tricky questions. It's saying, consider the weighted voting system. The smallest value of Q for all 3 players to have veto power. I've answered them all there, but how did I come up with those? For all 3 players to have veto power.
21.
Right, it's there. Now you got that by just adding them up. Yeah, but how would you know you're supposed to just add them up? Yeah, let me be helpful here. I know how you feel as a math student. I felt that way too as a math student. I'm like, give me the steps. What do? Do you just add them up? That's not the way this chapter works. I mean, I could write that down for you. I could say, if they ask this exact kind of question, and then let's say this exact, all 3 players, then yeah, add them up. But it's not going to be that way. They're just going to mix it all up. So it won't be exactly this, and you don't always exactly add them up. So that won't help you if I was to do that for you. Instead, I just want to help you to get in there and just kind of touchy-feely again, reason it out. That's what we have to be able to do in the end. And I know it takes time and practice. So let me help that way. Yes, you add them all up, but why? And the next one, it's not going to be add them all up. It's going to be all kinds of weird things, and they can easily change it. So how do you know? Well, here's what I would do. I would just get in there and I would just guess at first. I'm just going to guess at some number. I'm going to go, okay, some value Q, so I don't know. What if I make it 20? We know that's not the right answer. But let's prove that 20 is not the right answer. What's supposed to happen? All 3 players are supposed to have veto power. All 3 veto power. Okay, so tell me, who doesn't have veto power there? And how do you know?
1.
Right, good. Now, how do we prove that? How do you, this is your test, and it was on the line, you're wanting to answer. Maybe the answer is 20. Maybe, the A, B, C, D options, Maybe one of them is 20, and you're thinking, should I grab the 20? No, it's not 20, because 20 doesn't make them all 3 have veto power. How do you know? Well, remember how you test veto power? You cross them out, huh? You say, he says no, him alone. Veto means you alone say no. Him alone says no, and the other 2 say yes. Can he block it at 20? No, 12 and 8, that's 20. So they're going to pass it without him. So he did not veto it. He does not have veto power. Does that make sense? Right? Because 12 and 8 together make 20, which is enough to pass. So what I'm saying is, for quota 20, I'm going to go up now. I'm going to make it 21, 22, 23. I'm just going to guess. And each time I'm going to ask the question, does the lowest guy have veto power? Why am I doing the lowest guy? Well, think about it with me. If the lowest guy has veto power, then anybody bigger has to have veto power too, because they've got even more power. So that's really all I need to ask. Sometimes, based on the question, we'll start at the biggest number. It just sort of depends on the logical situation involved. So, all right, so we good so far? So everybody see that in this situation with 20, 1 does not have veto power. If he says no, it doesn't block it. They can still do it without it. He's not able to block. Right? He's not able alone to block. Now, if you put it up to 21, now he is able to block. Because now they need 21. So if he says no, they've only got 20, it's blocked. He alone can block it, huh? And so he's got veto power. And if he's got veto power, everybody bigger than him's got veto power. Don't even need to check. So they all 3 have veto power at 21. Now, what if you didn't start at 21? What if you started at something like 24? Let me do that. Right? What if you started at 24? What would you have found there? I showed you 20 doesn't work, but what about like 24? Well, let's think about it. Let me put this back the way it was. 12.8.1. Okay, so what if, now we're asking, what if 1 says no? If 1 says no, can he block it? Well, yeah, I guess kinda. How can they pass anything in the system? Do you realize that even if they all say yes, even if it's unanimous, that's only 21 votes. This is a system that can get nothing done. They can pass nothing, right? That's like saying it's going to take 101% of the population to elect the next president. Well, you can't do more than 100%, so nobody's becoming president, right? So that's an impossible system. So everybody see why the answer is not 24, not 23, not 22. They only have 21 votes. So the biggest you could ever make the quota is 21. You can't make the quota more than there are votes, right? That's impossible. So the biggest we could make the quota is 21. 21 worked. 21 made the 1 have veto power, right? And 20 did not. So the answer is 21. Is that okay? You feel like you could kind of reason that out on a test? This is actually one of the hardest things. In this chapter. Let's go to B. Feel free to speak up though, if there's anything I can say to help. Let's go to part B. B says, now find the smallest for what? What is B? P2 has veto power, but P3 does not. So now, for question B, I want to put a Q here, and it's 12, 8, and 1. And we want player 2 veto power, player 3 not. Player 2 veto power, player 3 not. So how's that going to work? Well, let's guess. Again, you're looking at the answer there, but let's just see how we would get there. What if, again, what's the biggest we could put here is 21, right? It's not right, but we'll see. But I can't put bigger than 21 because that's all the votes they have. You add them all up, right? Don't go bigger than 21. Now, why is 21 not the right answer? We know it's 14. We're looking at it. But why? Why is it not 21?
Because of 21 and they all have veto power.
Very good. So everybody with her on that? Because remember they're saying let P3 not veto power. Well, P3 does. In this situation, if the 1 says no, then these guys only have 20, not enough to pass something. So the 1 does have veto power, and we want him to not have veto power. So that's not right. So go down. We can't go up, right? Can't go up because that'd be more votes than they even have. So go down to 20. So why is it not 20 then? Put it back the way it was. Why is it not 20?
He still has power.
So if the 1 says no, remember how you ask you just keep crossing them out and say, okay, if 1 alone says no, does he have veto power? No, he doesn't, because they have 20 votes and I'm making it only 20. So 1 does not have veto power, and that's what we want. We want player 3 to not have veto power. So that seems right. But not only that, what else do we want?
So we want 8 to have
The 8, the player 2 to have veto power. So we verified that player 3 does not have veto power as we desired in this situation. But what about the other condition? What about the other condition? Let me go back into what if he says no? How many votes do those two have together? 13, only 13, right? Is that enough? No, they need 20. So did this guy block it?
Yeah.
He did. So does he have veto power in that situation? He does. Player 2 does. So what's going on here? Player 2 is got veto power. Player 3 does not. That's what they wanted. Why isn't the answer 20?
Smallest vote.
Very good. Smallest. That means there's more than one number that works. Give us the smallest one that works. See what they're saying? That's why these are so hard. There's more than one that really works. Yeah, 20 works, but I bet you 19 works and 18 works, and they do. We can tell the real answer is 14. 20 works, and I'll show you in a minute, but 20, 19, 18, 17, 16, 15, 14, all of those work. And then 13 does not. So 14 is the lowest one that works. That's why it's the answer. Let me show you. So we just saw that 20 works, right? So I'd come over here and I'd write, well, 20, that's not the final answer yet, but I'm just noting for myself. That's why these are, like, this is probably the hardest question on the next exam. 20 works. 20 does. Okay, great. But I got to find the smallest. That's hard. Smallest thing it works. So let me try another one. How about 19 then? Does 19 work? We'll see that it does. What is it supposed to do now? This guy's supposed to cross off and not have veto power. How many do they have? 20. So the 1 does not have, he couldn't block it. Right? They still have enough to get it done. 1 does not have veto power. Perfect. That's what we want. We want player 3, no, not veto power, but player 2, veto power. Does player 2, so what if, that's a comma there, sorry. What if player 2 says no? How much do we got there? 12 and 1 is 13, so player 2 blocked it. So player 2 has veto power, player 1 does not. 19 also works. So far the smallest number that works is 19. And then you just keep going and going and going and going. Let me go all the way down. So these can be pretty tedious, huh? Let me go all the way down to the bottom. These are, as I said, I think the hardest questions in this chapter. So if you go all the way down to 14, let me show you, that's the last one that works. So 14, well, let's go through it. If 1 says no, they still have 20 votes. So 1 did not block it. He does not have veto power. That's what we want. We want player 3 to not have veto power. Okay. What about the middle guy? What if the middle guy says no? Middle guy says no. 12 and 1 is 13. You see why 13 is not going to work? But 14 does. See, the middle guy blocked it. He yes, has veto power, and the guy at the back does not. They only have, without the middle guy, they only have 13 votes. Not enough when your mark is 14, when your quote is 14. So 14 works, on down, 14 works, but now when I change it to 13, you can see it doesn't work. Because if the middle guy says no, the other two still have enough. Now the middle guy doesn't have veto power at 13. So the lowest number that worked was 14. See, that's kind of tricky, huh? There was a whole range of numbers that worked, 14 being the lowest. Is that good? Is that okay? It is. It's challenging. And it's tedious. Yeah, these are the kind, I'd say these for last. Like when you take the real exam in a couple of weeks, do this last. Do all the stuff that's quick and easy, because this could take forever. You could spend 20 minutes fooling around with little examples and still not be sure in the end. You don't want to do that like early and then go, oh, I've got like 10 minutes left to do 15 other questions, which I could have got right if I'd done them first, Always when you take a math test, do the stuff that's easy first. Get all those done, and then go back to these kind of crazy ones. There's only going to be there'll be one of these on the next exam. This is like the separate the A's from the B's kind of question. There'll be one of these, and it'll be different, unfortunately. It won't be exactly this. They'll change something up, so you really have to get in there and think. So there'll be one of these. It'll be hard, and save it for last. All right, let's answer the part C. So we'll do this, then we'll get back to regular stuff that's more predictable and same every time kind of stuff. So, all right, so try C. What are they saying on C? They're saying smallest Q for what? Oh, P3 is the only dummy. Okay, so they want some kind of Q, and we got 12, 8, 1. They want this guy to be the only dummy. So they want P3 to be a dummy, but the other two to not be a dummy. Finding dummies is actually kind of hard. It gets a little tricky. It sounds so simple, but it's not. So you can tell I've given the answer there, but how would you know that? Do this for me, guys. How about, and gals, what if we just, let me just make it, I don't know, let me make it 20. Okay, try that on your own paper for just a second. See if you could figure out that it's 20 doesn't work. We're supposed to make only the one a dummy. See if you can figure out on your own papers why that's not the case. Why is it not the case that only, maybe they're all dummies, or maybe one's not a dummy at all? A couple different ways that could happen, right? You're supposed to make only the one a dummy. Maybe in this situation he's not a dummy at all. Or maybe they're all dummies. Or a couple of them are dummies. Then he's not the only dummy, right? He's supposed to be the only dummy. And I'm telling you with 20, he might not be. Or actually, maybe he is, but this is just the smallest. I don't know. Figure out. I really don't. As I'm talking to you right now, I don't have the answer in my head. I just have to work it out. I don't have some magic formula. I just work it out. So I'm going to give you a second. You'll get more out of it. I'm going to give you 30 seconds maybe. Does 20 work? I mean, it might work. I don't know. All right, is maybe that wasn't 30 seconds. Is the one, I'll go slow. Is the one a dummy? Let's just start with that question.
Yeah.
Is the one a dummy? How do you know the one's a dummy here? Because he never makes a difference, right? A dummy's somebody who never makes a difference, right? If 12 and 8 want to do something, they got enough votes, they got 20. If the one jumps in, he doesn't make a difference. It was already going to pass anyway. So he is a dummy here. That's true. So he's a dummy, but is he the only dummy?
Yeah.
Is maybe 8 a dummy? So to answer that question, remember, what a dummy never makes a difference. Is there ever a time when the 8 makes a difference? By him joining in, it takes it from failing to passing.
Yeah.
Yeah, when would that be?
12 and 1 would be 13.
Yeah, if 12 and 1 are wanting to do something, that's 13, or even just 12. And then 8, it's a no, but then if 8 jumps in, it's a go. He made a difference, so he's not a dummy. So this is a situation in which only one's a dummy, but we're supposed to find the smallest for which only one's a dummy. So that's one of them, but that must not be the smallest. Obviously 14 is. So same kind of thing. I don't want to waste up any more time. Let me just jump right to the answer. Why is it 14? Let's do 14 and prove that's the case. Is only one a dummy here? Would you know one's a dummy in the 14 case? Do you see it? Because see, one can never make a difference. If 12 wants to vote for something, he's a yes, and 8 says no, and 1 goes, I'll join him. That's only 13. He can't make a difference. Can't make a difference. So you see, 1's a dummy. He can never make a difference. But the 8 can certainly, if 8 joins in right here, that's 20 votes. 8's certainly not a dummy. But now, do you see when we go to 13, what happens? When we go to 13, what you tell me, what's the story? What's the issue that changes when we get to 13? Let me give you a second. Let me give you 30 seconds. I think you'll get more out of it. Tell me what's wrong on your own so you can figure out what's wrong with 13. We're trying to make only one be the dummy.
12 or 13 might be a dummy because 12 plus 1.
So what does that mean?
So that means 1 wouldn't be a dummy.
Well said. Does everybody see one's not a dummy? There's a situation in which 12 matters. I'm sorry, 1 matters. If 12 wants to vote for something and 8 is saying no and 1 joins him, he takes the day. He takes it from failing to passing. He made a difference. He's like, I'm not a dummy anymore, right? In this situation. He can make a difference, right? So see how it all depends on that? Because you might think, well, 1s are always dummies. Well, not if this is 13. Then 1 could matter. It all depends on that quota number, doesn't it? In this case, 1 is not a dummy. He would make a difference. If 12 and 8 were split, what 1 decides wins the day, right? There are situations in which his vote matters. He's not a dummy. So that's why 13 doesn't work. So what was the lowest number that worked? It was 14. So those are hard, tedious. You got to try several examples and work them all out. All right, let's get back to something a little more regular thing here. Okay, so we have the system. 17, 12, 10, 5, 2. So this is the quota, and those are the players. Okay, so you guys ready? You taking notes on this? So I'm going to do, this is going to be the whole kit and caboodle. What we're about to do here is what we're going to do again and again and again. It's going to take us like 15 minutes probably. It's a big process, but it's going to be the same every time. So this is like the main attraction now. All that was just kind of warm up. It's ball game on now. So this is really what we want to do in this chapter, is take a system like this, and in the end, our goal, the final question, will be to find the Bonshoff power distribution of this weighted voting system. In other words, I want to say when all is said and done, this guy has, 70% of the power, and this guy has 10%, and this guy has 8%, and etc. I don't know what the answers are, but that's our goal. In the very end, when all is said and done, we want to figure out how much actual percentage of the power the different players in this game have. So how do we do that? Well, several steps. First off, they're asking a couple silly questions. First off, what is the weight of the coalition formed by P1 and P3? Coalition just means a team. So we have player 1, player 2, player 3, and player 4. So if player 1 and player 3 get together, which is this guy and this guy, how much weight do they have? 17, yeah. So that's A. They're just checking that. Then B says write down all winning teams, winning coalitions. All right, so here's the real deal now. Here's what you really have to do. So I'm going to write all winning teams, coalitions, whatever you want to call it. All right, so here we go. So first off, I'm going to do all four-member teams. So if all 4 of the players get together and form a team, 12, 10, 5, 2, obviously they're going to win. They're going to pass. They all want to invest in Apple stock or whatever, and they're all there, unanimous. Well, yeah, of course, that's more than 17 votes. They're going to get their way. They're going to win. Now let's list all the 3-member teams, just where 3 of the players want the Apple stock and get their way. How could that work? Well, you can have the highest 3, right? Oh, you know what? Let me give you a system here. You guys with me? This is the kind of thing where you can't leave one out. What the skill that you really want to get in this section is being systematic. You have to have a way where you haven't missed even one. Sometimes in life you got to be precise, huh? So especially when they build bridges and things like that, right? We got to be precise sometimes. This is one of those cases. Let me help you to be that way. How can you make sure, as I list these, that I don't accidentally miss one? Well, do it with a pattern rather than kind of random. What I mean by pattern is, let's think this way. If they want me to list all the 3-member teams, we have 4 members all together, but I'm going to list all the 3-member teams. Well, an easy way to list all the 3-member teams is to just leave one out. Because if you leave one out, that's a 3-member team, isn't it? So just do that with a system. So first off, I'm going to leave out the 2. There we go. There's the team having left out the 2. Next, follow the pattern. Who am I going to leave out next? I'm going to leave out the 5 and go 12, 10, 2. Next, I'll leave out the 10. That's 12, 5, 2. And last, leave out the 12. 10, 5, 2. And I know I've got them all, huh? Because I used a system. See how that is? So I know I didn't miss any. So I used a system, and we'll always do that. We'll always do just leave one at a time out and list the other 3. So those are all the 3-member teams. That's all the different 3-member teams. No way we missed one. Okay, now, are those all winners, though? Do those all have at least 17 votes?
Yeah.
Yes, they do, because even the lowest one here, that's 17 votes, and the other ones are even higher. Good. So yeah, those are all winning teams, aren't they? Those are all winning teams. Now, we want to list all the 2-member winning teams.
Just 12 and 5 and 12 and 10.
Yeah, I think you might be right. Yeah, I think you're right. So now how to do that? Start at the 12, start at the biggest one, and you're just going to do 2-member teams, right? So do 12 and 10. Right on the money. That's certainly a winner. They have 22 votes. They certainly have 17 or more. And then 12 and 5. I think you're totally right. Yeah, nothing else is going to work. You can check it. 12 and 2 is only 14. It's not enough, right? And so that was all the teams starting with 12. So now if I start with 10 and go down the line, 10 and 5 is only 15. It's not 17. And 10 and 2 is even lower. Start at 5, 5 and 2, clearly not. So yeah, those are all the winning. But do you see how I did use the system to make sure I checked the other ones? Again, you can't miss even one or everything's thrown off. Is that good to there? So those are, and there's no 1-member teams. That would be a dictator. Nobody can win alone. So those are all the winning coalitions, aren't they? Now, Math Excel, when you click on the help, or even when you just choose the answer, they put it in weird. I don't like their system. So I just want to give you a heads up. They'll go P1, P2, P3, P4. Like that, instead of listing the numbers, and then here they'll go, that's what they always do, which is fine, but I think it's a little easier just to see the numbers. But I just want to let you know that's what they will do. All right, so now, question C. Which players are critical to the coalition P2, P3, P4? Any questions on this so far as I'm moving along? So we're going to focus on a new thing. I want to make sure you're with me. All right, P2, let me bring it over here for just a minute. P2, P3, P4. Who is that? P2, P3, well, it's these three, huh? Right? 10, 5, 2. That's the P2, P3, P4 team. 10, 5, 2. We good? Now, what's their question? Which players are critical in that team? Now, what does critical mean? Yeah, necessary, huh? Gotta be there. My 13-year-old boy, he played Little League 2 or 3 years ago, I can't remember anyway, and they had that year on his Little League baseball team somebody named Anthony, and he was a monster at 12 years old. I think he was as tall as me. I think he might have been a little taller than me at 12 years old. I think he was about my height, right? At 12, 6 foot tall. At 12 years old, right? So I remember the first day of practice out there. I'm out there watching the kids throwing the baseball. I wasn't the coach. I was helping the coach, And then this one kid showed up. I thought he was a coach, and he was one of the players. Well, when we played our games during the season, Anthony was critical. Basically, it was simply this. If Anthony showed up, we won. If Anthony didn't show up, we lost. It was pretty much like that. Anthony was not only big, he was awesome. He played, and he didn't always show up, so it made it kind of interesting. We'd always be watching at the start of the game, because Anthony was a superstar, so he not only played in our silly little League team, which I think he thought was kind of silly, he also played in travel ball, and he played in the school ball, because he was, and now I heard that he's still around, and he made the varsity team at Clovis or something his freshman year. He's like a superstar. He threw out the baseball at some big event. Anyway, he might make the pros or something someday. So anyway, he's just awesome. So we never knew though, because he had so many commitments in town, so many different baseball teams he was on. So we never knew, So to be about game time, we're like, boy, I hope Anthony comes in. Oh, there's Anthony. We're going to win today. Anthony's here. Still, that's what critical means. Somebody's critical. If they're there, you win. If they're not there, you lose. So let's take a look. In this coalition, if they don't show, so what you want to say critical, let me write it out real clear, because this is what we're going to do a whole bunch of now, is we're going to say who's critical. So critical means, let me be real clear, you drop out and the team loses. You drop out and the team loses. If you drop out, the team loses. That means you're critical, right? Whereas if you don't show up and the team still wins, that means they really technically didn't need you that day. You weren't critical, right? So critical means you don't show up, they lose. All right. So here we go. Let's give it a try. In the 10-5-2 team, that's the P2, P3, P4. That's what they're asking me about in question C. If 2 doesn't show up, 2 doesn't show up that day, do they lose without him? Right? That's the thing. You drop out, the team loses. Do they lose? What do they got? 10-5? 15? What do they need? 17? Do they lose? Yeah, they lose. So 2's critical. They need him. If 2 doesn't show up, they lose. Well, how about the 5? What if the 5 doesn't show up, but the other 2 do? Yeah, 5's critical also, because 10 and 2 lose without the 5. Exactly. And if the 10 doesn't show up, 5 and 2 lose. So they're all 3 critical on that team, aren't they? And of course, you know what? It makes sense. If the lowest guy's critical, the higher ones have to be critical too. How could a lower number be critical and the other one's not? So once you find critical, anything higher than that's got to be critical also. Does that make sense? So yeah, see how I circled them? Well, I've done a lot to them. But anyway, all 3 are critical. All 3 are critical on that team. Now, it won't always be that way though. Here we go. Now, finally, that's all just warm up for the final question. Find the Bonshoff power. How do we do it? We go through every one of these winning teams, player by player, and we ask, is he critical? Is he critical? Is he critical? Is he critical? Right on through. We can't even get one wrong, or it's going to be wrong. So here we go. So I'm going to ask one at a time which ones are critical. I'm going to start at the lowest one, because once I hit critical, they're on up as critical, right? Let's start with 2. I'm going to start with a 4-member team. I'll get to the 3-member teams in a minute. Is that too critical? Meaning, what does critical mean? Here it is again. You drop out, they lose. Do they lose without him? No, they still got plenty of, they're still way over 17 and over. All right, this is 20, whatever, 27. So no, 2 is not critical. 2 doesn't come, they don't lose. So he's not critical. All right, let's go up the line. How about if the 5 doesn't show up? Do they lose? No, they still win. So 5's not critical. You with me? Neither 5 nor 2 are critical. How about 10? If 10 doesn't show up, do they lose? No, they got 12 and 5 and 2. They got whatever that is, 19 votes. No, they don't lose. 10's not critical. Right? When Anthony didn't show up, we lost. Right? That's critical. That's critical. All right, so 10's not critical. They can win without him. How about if the 12 doesn't show up? No, they can actually win without the 12. 10, 5, and 2 is 17. So, no, 12's not critical either. None of them are critical on that team. That's a real strong team. Nobody is absolutely necessary. You can drop any of them off and they're still going to win. Nobody's critical. Let's go to the 3-member teams now. How about if the 5 drops off of this team? Do they lose? No, they still got 22 votes. So they still win. 5 is not critical. Let's do next the 10. If the 10 drops off, do they still win? Yes. 12 and 5 is 17. So it's not critical. They're supposed to lose without you. That's when they're critical. When you're critical, right? Is everybody with me on that? The 10 is not critical. The team doesn't lose without him. How about the 12? That's our first critical player. In that situation anyway. In that situation, the 12 is critical. Everybody see that? If the 12 doesn't show up, the 10 and the 5 lose. They've only got 15. You need 7. Remember the quota is always what we're aiming at, right? You need 17 to win. 12 doesn't show up, they lose. 12 is critical on that team, right? I imagine Anthony's probably not critical on this varsity Clovis team, but he was critical on our team. So 12 is critical on that team. He's the only one that's critical on that team. He's the only one that's got to be there, right? That if he drops out, they lose. Let's keep going. So by the way, let me hold on right there. Do you know what that means about the 12? He's exercising real power on that team, isn't he? You with me? Right? I mean, that's real power. Right? That'd be like us looking for Anthony. If Anthony, he had the power. If he came to our game, we won. If he didn't come, it wasn't so much my son. Although he was good and everything, but he could not come, they'd still win. Right? So he didn't have any real power. The 12 has the real power here. Right? If the 12 doesn't show up, they lose. If he does, they win. He's making the difference, isn't he? That's real power. If you never make the, that's what it means to exercise power. You're in, it passes. If he decides he likes, 10 and 5 want the apple stock, and he says, yeah, I like it too, then they're going to go apple stock. If he says, no, I don't like apple stock, they're not. He has the power. In that situation. There's other situations, and we'll see who has the power in other situations, but in that situation, only 12 is exercising any real power. Does everybody see that? Do you feel that? Do you see what I mean? Like, why is the 5 not, or how about the 10? Even the 10 is not exercising power. What? Because if the 10 says, I don't like apple stock, the 12 and the 5 say, whatever, we're still going to do it. We still got 17. So 10, you're not making the difference. Right? 10 has no real power. 10 can change his mind, and nothing changes. So that's not power. Right? You with me? Only the 12 has power on that team. Let's keep going. How about the next one? Maybe we should start with the biggest one. Does 12 have power on this team? Meaning if he says no, do they lose?
Yes.
Yeah, they need him. So he's got power. Okay. How about the 10? What if the 10 says no? Do they lose? Yeah, he's got power here too. Do you see that? If the 10 drops out of this next team now, if the 10 drops out of this team, 12 and 2 can't get it done. They've only got 14. They need to have 17. So if 10 drops out, they lose. There's 2 critical players, 2 Anthonys, right? They need them both. If the 10 drops out, they lose. So the 10 is critical there also. What about the 2? If he drops out, do they lose? No. So he's not critical on that team. So I'll circle them. You can underline them, circle them, whatever. Somehow mark them off as the critical people. So there's 2 people that are exercising real power on that team. If either one of them drops out, that team loses. So that's real power. That's when they're both making a real difference. If either one of them doesn't show up, that team, which is now winning, it's now winning, this is all the winning teams, that team which is now winning will become a losing team. If either one of those guys doesn't show up, they're both exercising true power, right? They're making a difference. Let's keep going. If 12 drops out of this team, do they lose?
Yes.
They lose, right? If 5 drops out of this team, 5 drops off, do they lose? Yeah, 12 and 2 is not enough. If 2 drops out of this team, do they lose? No, they have 17 without him, right? If 2 drops out, they still have 17. So 2 does not have any real power there, right? He can drop off, and they're not going to lose. Oops, it still looks like it's circled. So just the 12 and the 5 have the power there. Try the third. Try this one. Let me give you a second. Rather than me just lead you through it. Try that one. So cross them off one at a time and ask yourself about the power. Okay, what do you think? Let's start with the 10. If the 10 drops off of this team, do they lose? Yeah, they only have 7 votes. If the 5 drops off of this team, do they lose? They only have 12 votes. He's critical. If the 2 drops off of this team, do they lose? Yeah, even the 2's critical there, right? Because they'd only have 15 votes without him. So 2 does make a difference sometimes. It just depends on the situation. So you see what I mean? It depends on the situation. So here's the place where 2's making a real difference on this team. All right, let's go to the 2-member teams. If the 12 drops off, does the team lose? Absolutely. He's only got 10 votes. If the 10 drops off, well, yeah, then there's only the 12. That's not 17. Yeah. See, they're all going to be critical. On these 2-member teams, they're almost always all critical. A 2-member team, you need them both. They're all critical. If any one of these guys drops off of these teams, those teams become losing teams. They're winning right now. All right, so we circled every time that real power was exercised. Do you agree with me? Right? Every time I circled something, that was a time when that person was making a difference, right? If this 12 up here drops off of this team, they become a losing team. If he stays on, they're a winner. Or right here, the 12 and the 10. If either one of them drops off, they lose. If both stay, it's win. So now those are real power. That's the only time that's what power is, right? Power makes a difference, right? So those are the only times real power is exercised. So how many times was real power exercised? How many total times did we circle things? Let's count them. Is that what it is? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I do that right?
Yeah.
So it looks like 12 times things were circled. So let me run out of room here. So we're ready to give the power now. We're ready to answer the question. So player 1, player 2, player 3. Oops, I shouldn't have spaced that out so much. So I'll do it up here. Player 1, player 2, player 3, and player 4. I'm going to put a 12 denominator for each of these. Why? Because that's the total. Remember, we're looking for what percentage. What does percentage always mean? Part over whole, as we talked about a few minutes ago, right? Percentage means part over whole. Are we almost out of time?
Yeah.
Man, this time it's a little bit. Okay, part over whole, part over whole, part over whole, part over whole. So there was 12 whole times that power was exercised. 12 different times. What part of those times when real power was exercised did player 1 exercise power? Player 1's the big guy, the 12. How many times did 12 exercise power? 1, 2, 3, 4, 5. 5 times out of the 12 times power was exercised, 5 of those, it was player 1. He has 5/12 of the power. Right? 12 times real power was exercised. There's 12 different scenarios in which real power would be exercised, and 5 of those have almost half of the time is player 1. How many times did player 2? Player 2 is the 10. So it'd be 1, 2, 3. 3 out of 12, you can reduce that to be 1/4. Right, divide top and bottom by 3. How about player 3? Player 3 is the 5. How many times? Yeah, 5. It's a 1, 2, 3. Yeah, 3/12, which reduces to be 1/4. So notice, look at that. Player 3 has the same power as player 2. Really, when all is said and done in this situation. Player 4, 1 time out of 12. There's only 1 time when player 2 exercises. He's not a dummy. He has some power. He's almost a dummy, but he's not a dummy. So then I don't know if they want fractions, or if they want percentage, just divide in your calculator. If they want fractions, just leave them as they are. You should double check. They should add up to 12/12. Double check. When you do this on the test, you want to double check. 5 and 3 is 8, and 3 more is 11, and 1 more is 12/12. Yeah, so I didn't miss any. That's all the power, and that's the different percentage of the power. So we're able to take a weighted voting system and find out where the power actually lies and what percentage of the power people have. Perfect. That's just perfect. We finished the section